I am trying to tell a story of how I understood nature one day. This happened 20 years ago. I was contemplating nature. This was in India, in the south of India, in Kerala. Kerala, which in Sanskrit means God's own country. I was doing nothing. I took a sabbatical year and I was just exploring the ancient science of Ayurveda and yoga. I was trying to understand how the ancient rishis in India understood and explained nature. So I was looking into these wonderful books and knowledge that is something that belongs to humanity, not just to Hinduism. It's science that Ayurveda means science of life. So it's a science that explains everything in nature. Very interesting model, but very different to what we have seen in college and at high school. Very different to what I was teaching. The model had this very simple initial idea. Everything in nature is surrounded by 5 elements. They call these 5 elements let's put it in blue. So Sanskrit, the Mahabhutas. I think it's Bhutas. So Mahabhutas means 5 elements, right? There are 5 elements in nature, as we all understand. It's very simple to understand. This is not just coming from the Sanskrit or the Sankhya philosophy. This is part of every ancient knowledge system in the world, right? The 5 elements are space. We know that 99.9% of everything that is outside of our body is mainly space. So space is present inside the stars, outside the stars, around the stars, in between the galaxies, in the air. The air is mainly space. Water, of course, the earth, our bodies, inside our bodies, the atoms that make our body are also 99.9% space. So the macrocosmos and the microcosmos is mainly space. That word that the ancient rishis used to name that element that is present in nature is akasha. So this is the first Sanskrit word that defined space as an element of nature. Everything is made of akasha, and akasha is quite a mysterious element. There is a lot of energy inside space, as we will learn as we go deeper and deeper into the nature of space and how matter and antimatter pop out into existence from space. Space has a lot of surprises, and it is certainly not vacuum, certainly not absence of energy. Then, of course, the sun, the solar energy, the source of all our energy in Earth, what keeps us warm, what feeds us, what transforms into matter through photosynthesis. This also was honored and in all ancient civilizations as a god. And it is, in fact, where the energy that we use comes from. So this was named as Tejo, solar energy, sun, also present outside and inside our bodies. The air that is all around us, if the air that covers the earth, if we take the earth into the scale of an apple, the air that covers the earth, the atmosphere, that sphere of air that is all around the earth is as thick as the skin of the apple. So it's a very thin and delicate layer of air that we need to keep clean and protect, because it's all we have, Global warming is affecting mainly the air. The water, the element of life, as we all understand now, the water that cycles in nature. Our body is 70% water, so we are connected to the water whether we know it or not. Everything we eat is water, so all of this water that is around us is also inside of us. In fact, we are only just part of the water cycle. And the earth, Mother Earth, Prithvi, Mother Earth. It's, of course, the element that supports us, that gives us stability, that carries our body, that feeds us also because the food comes from the earth. Um, so these are the elements of nature. And I was thinking there should be a relation between the elements of nature and the different fields that we study in physics. And this was probably one of the first big like wows that came to me, you know, an exclamation, wow, I have an idea. Maybe everything that happens on the earth, everything that is related to the motion of bodies, mass, weight, all that has to do with what we study in mechanics. Definitely the forces that attract bodies, even outside of us, the mechanics of the universe, the laws of gravity, all that is mechanics. So that is what we study in the first units of science physics. When we look at the element water and we study how the water is used to, for example, transfer energy and pressure and machines that work with hydraulics energy, we could also consider that hydraulics related to physics and water. A lot of, you know, machines, systems that use hydraulics to work. Oh, let me go back. Systems that use hydraulics to work. Of course, the air is the study of all the gases, molecules that move at random motion. We're going to start studying this now when we study gases, molecules. P5 is about understanding the nature of the kinetic theory of gases. So here I'm going to just put the word gases to remind us that there is a field of physics that studies these gases. And tejo, fire, the heat, what we call heat in science, thermodynamics also. These are the fields in physics that we will study. No? The use of solar energy to move things, how we can absorb and retain that energy and transform it into mechanical work, for instance. The steam engine, all these great discoveries that change the world. And everything that happens in space, if you think about what happens in space, like thunder, lightning, currents, you know, electrons moving from one place to the other inside our body, in our nervous system, but also outside of our body. So here we have electricity. A lot of fields in physics are related to space. Space is the biggest element. Electricity, electromagnetism, nuclear physics, astrophysics. A lot of fields, quantum physics, are related, connected to the space element. Waves, you know, when you study waves, electromagnetic waves, we are studying energy that travels through space. So basically 5 elements of nature, 5 systems in nature, 5 ways of looking at nature from the lenses of physics. That was my first discovery. Okay, so there is a connection between physics and, let me put here the word just to remind you that this is not coming from me, Ayurveda. This is the science of life, the ancient science of life. Okay, what is next? The first thing that came to my mind was, okay, what are we looking at? What is it that we observe? When we decide to look at something in science, we make it real. We say, okay, this is what we look at. So for instance, we have seen just now, we were looking at bodies. And we were looking at the mass of the bodies. That means something like the amount of matter that the body has. We explored the concept of volume, the amount of space that they occupy in cubic meters, and then also the connection between mass and weight. Mg equals weight. So the force that pushes an apple, for example, towards the earth measured in newtons. And of course, we have seen the concept of density also, right? So density, mass, weight, volume. These are the concepts that we started looking at, very concrete and very easy to measure through balances, Newton meters, measuring cylinders. We did all this when we started with physics this year. So what are we observing? Now, if we start looking at water, I am going to explore the same ideas for water. We could think of a mass of water. We could think of, for example, 1 kilogram of water as a mass of water. That will create a force of 10 newtons, because the gravity is 10. So we could look at the idea of the weight of water. And mainly what we use in physics when we explore water is the volume. So the volume is the amount of space that water occupies, and it's measured in cubic meters. So if we're looking at a volume, at a mass of 1 kilo, the volume is 1 cubic decimeter. But let's think of a big volume. Let's think of 1 cubic meter. So this is a big volume of water, right? A sphere that has 1 cubic meter. But that means 1,000 liters of water. It's a big volume. So we're looking at that amount. What happens when we look at the air? Well, the density of the air is smaller than the density of water and smaller than the density of earth. That's why the air is above the water, right? And above the earth. So also we could think of mass of air, we could think of volume of air, and I think we're going to use the concept of volume also in cubic meters of air. So we're looking at a bigger volume of air here. This would represent 1 cubic meter of air. So we're looking at an amount of air that is moving in and out of our bodies, for example. When we breathe, in one day, more than 10,000 liters of air pass through our lungs. And that air is coming from the atmosphere and then going back to the atmosphere, right? It's a very important process because it gives us oxygen energy. So we have to look at this amount of air as if it was a balloon full of air, amount of water, amount of matter. Now, when we look at the sun, and this is a question that I asked myself then, what is coming from the sun? And we could think of an amount of energy. We could think of 1 joule of energy, because we know that the sun is the first source of energy, right? Everything that we do on Earth comes from that solar energy. It gets transformed into chemical energy, it gets transformed into other forms of energy, but even me now speaking here, it is because of the sun. Everything that happens on Earth is because of the sun. So energy could be defined as that which comes from the sun and makes all system work. If we have to imagine something coming out from the sun towards us, we could look at the idea of packages of energy, tiny packages of energy traveling at the speed of light, and those are called photons. That we will explore later on. But basically, we accept the idea of energy as that which comes from the sun, and that's it. It's just accepting the concept of energy as anything that comes from the sun and then gets transformed. And then when we think of an amount that is related to everything that happens in space, like I said, electric currents, even inside a nervous system, when we're thinking, there is just a flow of electrons moving, jumping from one neuron to another neuron. So we could think of charges, an amount of charge that could be defined as an electron, or the initial idea was that charge was positive. So we could define that as let's say, an amount of charge in a unit that we need to get familiar with later on, but we'll call it Coulomb. So what is Coulomb? Coulomb is a positive unit that counts as amount of charge. So something is moving when there is lightning, when we are thinking, when there is a current. There is one charge jumping from one place to another, or energy coming from the sun, or air moving as wind, or water moving as a river, and bodies just moving on Earth. These are the things that we explore, that we observe in physics. This is what we are observing. That was the first idea. But if something moves, then there must be something pushing. Nothing moves without something that pushes. So I started thinking about the concept of potential difference. Potential difference means something is pushing that variable. And we have seen an apple falls because there is a difference of height. This letter delta means difference of height. I mean, an apple would not fall to earth if it wasn't on a tree. So for something to move, it needs, for a stone to roll down the mountain, it needs to be at a certain height. What makes water move? We could think of difference of height also, because a waterfall has, the ability of transforming gravitational potential into kinetic energy. But also we could think of water going in the opposite direction, like, for example, blood coming up to my brain. And that is being pushed by pressure. And we saw this concept, pressure, in pascales. So liquids could be pushed upwards by exerting pressure on them. This is how we pump the water to bring it up the roof and store it in tanks. Same thing happens inside the body. This is the roof. Okay? And when we think about the air, what is pushing the air in and out of the body, the answer is also pressure. Air is moving in and out of the body because there is a difference of pressure inside the lungs and outside the lungs. Difference of pressure is pushing the bodies, again, in pascals, force per unit area. Interesting, the first act of life was just to allow the air in, to inhale. It is not something we do, it's something that nature does for us. The atmospheric pressure is pushing the air into our bodies. So the last act of life is exhalation. We push the air out and we relax. Think about this. When we were born, we inhaled, and then everybody laughed, and then we cried. Second act of life, we cried. First we inhaled, then we cried, and everybody else laughed. And if we live a good life, when we die, we will exhale and smile, and everybody else will cry. That's a good life. Now, what pushes these photons, these particles, or these rays, if you want to call it, or this energy that comes from the sun? What is pushing this energy? Why is the sun sending energy to the earth and not the other way around? Why isn't the earth sending energy to the sun? This is a big question, and the answer is a concept that we are all familiar with. It is a difference of temperature. So temperature is not the same as, well, Kelvin probably is the international unit for temperature, not Celsius. It's not the same as energy. Temperature is potential difference. Temperature shows the direction in which heat is transferred, while energy is that which travels from the sun to the earth. And lastly, we will look at charges, positive or negative charges, that are being pushed by difference in potential that we call voltage. Difference in potential difference, we will see this when we study electricity, but the potential difference is represented by a battery that pushes the charge. We will explore this later on. So these are the two things that we need to understand in nature. Something moves, and something moves because something pushes. So far, so good.